Hi, everyone. Welcome to today's episode of the Golden Path to Spring One. If you were here on Tuesday, nice seeing you again. Or if not, maybe it's been a while. So yeah, we're still doing these every Tuesday and Thursday. You can go to tanzu.tv and you can see all the upcoming episodes that we have. This is basically leading up to the in-person Spring One conference that is co-located with VMware Explorer. That starts on August 21st in Las Vegas. So please be there. I will be there and giving my first VMware conference talk, so that'll be kind of cool. But yeah, so I'm here today with Mahmoud, and the talk is going to be on what's new in Spring Batch 5. I'm over here in Seattle. Feel free to share in the comments wherever you're from. And yeah, Mahmoud, where are you right now?
So, hi everyone. I'm in France. I'm in Lille, not far from Paris. For those who don't know this city. Thank you for having me. It's a pleasure to be on this Golden Path to Spring One. And yeah.
Yeah, I've never actually been to Lille. I've been through it to go to Belgium though.
Okay, good, nice.
And
Yeah,
yeah,
it's not
so
far from Belgium.
sorry, say that again.
It's not far from Belgium. It's actually between it's on the side. So it's 1 hour from Belgium, I think.
Yeah, I think that's about what it was when I was there a month, 2 months ago. I don't know. Time just kind of like goes away at this point in time. Um, yeah, so if folks have any questions throughout, please put them in chat. There's actually one there already. I don't know if this is something that you know, but I'm going to ask. So how can one make the proper distinction between, I assume, JS is JavaScript framework and a library as it relates to applicable networking on a particular device? I have no idea.
So let me check. How can we make it? Yeah, I think JS libraries are typically on the client side. What we are presenting today is a batch framework that is like for data processing, usually on the server side. I'm not sure if I understand the question, but yeah, this is, I think, a little bit what I understood.
Sweet. Yeah. So yeah, I will let you go ahead and kick it off. I will pull up the slides and disappear.
Okay. Thank you. Thank you for the introduction. So welcome everyone to this presentation. My name is Mahmoud. I am the lead of Spring Batch at VMware. I joined Pivotal VMware 5 years ago now, and I have been working on Spring Batch since then. I mainly work on Spring Batch, but I also contribute to other projects where Spring Batch is used, like Spring Boot, Spring Cloud, and so on. So in today's session, I wanted to share with you what's new in Spring Batch 5. So this is a big release. We have been working on it for 2 years. We've got dozens of contributions. So I would like to take this opportunity to thank all contributors who had a role in this release. So the presentation will go like this. I will start by presenting the new baseline. So for every major release, we have a new baseline, both in terms of minimum Java version and Spring dependencies. After that, I will walk you through the major features in this release, and then I will show what we have removed from this release. And I will finish by giving some important details about the support policy for the current version and the previous version, and show you what's coming next after that. So for the baseline, as with every major release, we take the opportunity to upgrade our Spring dependencies to their latest releases. So for Spring Batch 5, we upgraded to Spring Framework 6, Spring Integration 6, Spring Data 3, and so on. And all of these are major releases as well. So here, my Parameter Java.10 is also a major release, despite the minor version number there. But yeah, those are the Spring dependencies that Spring Batch is based on, and which we upgrade to their respective major releases every time. Now, as you might know, Spring Framework 6 requires Java 17 as a minimum Java version, and Jakarta EE9 for the Enterprise Edition. And so since Spring Batch is based on Spring Framework, we also had to upgrade the minimum Java version for Spring Batch as well. So in this release, we also upgraded to Java Standard Edition 17 as a minimum Java version, and for the Enterprise Edition, it's Jakarta EE9. So yeah, this is like it was like a bit controversial when we announced that we will be using Java 17 as a minimum Java version for Spring Framework, and of course for the entire portfolio following. But I think this is a good choice and the right choice, because if you think about it, like with the release cadence of Java from Oracle twice a year, we have from in 3 or 4 years or 5 years from now, we will have like 10 Java versions released. We are already on Java 20, I think. So in 5 years, we will be maybe on Java 30. And if we stay today on Java 8, which is the current baseline, we will have to support from Java 8 to Java 30 from now to 5 years from now. So which is, of course, a very long time frame, and we can't really do that. So that's, I think, the right time to upgrade to the latest LTS version, which is Java 17 for the moment. And yeah, I think this is a good platform to run batch applications on, because every time there is a new JDK release, there are improvements in terms of startup time, memory management, and so on. And I wanted to share here like a presentation from an Oracle program manager who talks about the new versions, new features from Java 8 to Java 18. And at some point in the presentation, he talks about the startup time improvement. And here there is like a chart of the startup time of a Hello World application between different JDK versions. And we see like between JDK 8 and JDK 17, the startup time is almost 2 times faster. So I think that's already a great improvement just by upgrading to a newer Java version. And a bit later in the presentation, he also talks about the memory footprint improvements. Here it's the same idea for the same application, the same garbage collector. We see that like the improvement, the memory footprint is a lot better. So here JDK 8 is the blue line, and the gray line is JDK 17. So we see a big improvement here as well. So yeah, moving to Java 17, I think, is already a feature. We will have many performance improvements just by upgrading to a new Java version. The other key point about migrating to Java 17 is it's not only for performance, but also for features. Like we have new features in the JDK that we can use as framework developers to implement new features in Spring Batch. And talking about new features, I'm going to show one example where having Java 17 as a baseline allowed us to improve, to implement new features. The first new feature I want to talk about is the Java record support updates. So Java records were like introduced in Java 14 in preview, and they were out of preview in Java 16. And when they were introduced in preview, we tried to like introduce support for them in Spring Batch, so that we give a feeling for users about how they can be supported in Spring Batch. And at that point, Spring Batch 4.3, which is based on Java 8, we didn't have like the Java lang record APIs in the JDK. So we try to like emulate or try to support Java records without really having the correct APIs in the GDK. Anyway, so we introduced the support for Java records in 4.3, and since then we fixed a couple of bugs. We added like a couple of new features. The one I wanted to mention here is the record field extractor for Java records. So this is like similar to the bean wrapper field extractor for Java beans. So this is the API that allows users to extract fields from Java objects to marshal them, for example, or something like that. And we didn't have something for Java records, and we introduced it since 4.3. What we've added as well is the usage of the Java lang record API, which wasn't available in Java 8. So now we remove all the reflection hacks we had to support records in Spring Batch 4, and we fixed the implementation by using the correct APIs. And this also allowed us to like add some new features like the automatic configuration of mappers in item readers based on the item type, and also the extractors on item writers based also on the item type. So for those who are not familiar with these, like mappers are like what we use when we read data from a flat file or a database. So we map data from a raw format to Java objects. So this is where we use mappers, and extractors are, on the other hand, when we write data from Java objects to like a file or a database, and at that time we need to extract fields from objects and marshal them. So in these two places, like we used in Spring Batch 4 to configure these mappers and extractors manually. And now in Spring Batch 5, we can map them automatically thanks to the usage of this API. And I will show an example here, a very simple example to explain this new feature and why it's important. So for example, let's say here I have a person class with two fields, ID and name. And I want like to configure a flat file item reader to read some data from a person.csv file. Okay. So this is how I configure a flat file item reader in Spring Batch. So I use a builder. I specify the resource, which is the file from which I'm reading data. And then I tell Spring Batch the target type, person.class, which means the type to which Spring Batch should map each line of this this file to an instance of this class, person.class. Now, when I configure this this item reader like this, I'm expecting that Spring Batch will set a bean wrapper field set mapper on this reader. So this is a class, so a regular Java class, and the mapper for it is this one, bean wrapper field set mapper. Now the question is, what if I change this person class to a record, like here? So like, suppose I want to migrate my types to records when I move to Java 17. Now I'm expecting from Spring Batch that it sets a record field set mapper. So it will change the implementation of the mapper based on this target type here. And this is what we have done in Spring Batch 5. The importance of this point is that when you decide to move your classes or types from classes to records, the idea is that you don't have to change the configuration of the item readers and writers. This is very important because sometimes those types are not under our control, so they can come from a jar that we didn't really design. And if those people who design those types decide to move from classes to records, Spring Batch users will be covered by this feature. So we don't have like to change any configuration of the reader or the writer and so on. That's the importance of this feature. And of course, this is possible thanks to this Java lang record API, which we use inside this builder here. So we can introspect the type, and here is the example. So somewhere in the builder, when we build the flat file item reader, we can like introspect the type, see if it's a record or not, and then configure the right mapper on it. And we use this in almost all the readers and writers where we set this kind of components, and that was not possible in Spring Batch 4. Now it's possible in Spring Batch 5. So yeah, that's the kind of niceties we can have by basing the framework on Java 17, which has new features. So we can implement new features in Spring Batch. Okay, so the second feature I want to talk about is the batch configuration updates. So this is like impacting end users, and the idea here is to improve the way we configure Spring Batch. So we have two ways: a declarative way with an annotation and a programmatic way with a class. And I will show both of these. So enable batch processing is the annotation that we use in Spring Batch to declaratively configure infrastructure beans. And for those who are not familiar with this annotation, so it's like an old one, I think, from Spring Batch 3. So we add this annotation on a Spring configuration class. And this annotation will register in the application context some infrastructure beans related to Spring Batch. Like, for example, the job repository, job explorer, and so on. And like, for example, here, I have the job repository, which is auto-wired from the application context here, and I can use it to create my job, for example. So nothing new here. This is the same way of working. What we have changed in Spring Batch 5 is the way we customize this annotation. So how, for example, I customize the job repository that is registered by that annotation. So in Spring Batch 4, the way to configure this annotation is by implementing an interface, which is here, batch configurer. So I need to provide a bean of this type and override a method, like, for example, here, get job repository. So in this example, I want to use a custom data source. And for that, I need to implement this interface, override this method or extend this class, override this method, and provide my custom job repository. And if we think about this, since we are in a declarative approach, we are not expected to write code, like implement an interface or extend the class. So it's like a mixed approach, declarative and programmatic, and this is problematic in my opinion. So what we try to do is, like in the declarative approach, being purely declarative, meaning how can I try to configure Spring Batch to use this custom data source without implementing an interface or extending the class? And the idea we had is to use attributes of this annotation. So for example, if I add an attribute here, data source ref, and I can point to a data source bean, which is in my application context. Now I can like customize the behavior of the annotation without implementing an interface. All I have to do is declare my data source bean in my application context and tell Spring Batch to use it for the job repository and so on. So this is what we have done, and now in Spring Batch 5, this is the way to configure Spring Batch through the annotation. Of course, this is purely declarative. If this data source here is auto-configured by Spring Boot, for example, imagine I don't have this bean here, I can still point to it through this attribute, and yeah, it's purely declarative just by adding an attribute on the annotation. Yeah, so for a single property, maybe it's not too impressive because it's not a lot of code that we removed here, only this bean. But sometimes for a property which is set on the job repository, the job explorer, and maybe another component, we have to write a lot of code. Like, for example, here I have another example where we have to customize the execution context serializer, for example, if I want to customize the serialization format to my database. In this case, I have to implement this batch configurer and override two methods, get job repository and get job explorer, because I need to set the same serializer on both sides when I serialize with the job repository and when I deserialize with the job explorer. So I need to set this custom serializer here and here as well. And of course, for a single property, we see that there is a lot of code here and it can be buggy and so on. And there is something wrong with this, and we don't like you to write all this code. So the idea is the same, is to add an attribute to the annotation, and Spring Batch will use that custom serializer to set it on where it's needed actually in the job repository, in the job explorer, and so on. So I literally remove all of this code and yeah, replace all of this by just an attribute here. And I think this is awesome because, of course, less code, less bugs, and less maintenance, and so on. And it's even more intuitive and more easy to think about. So yeah, that was the declarative approach with an annotation. Now, what if I want to take control on the configuration and write some code and customize the configuration through code? And that's why we introduced a new class called called default batch configuration. So it's this class, which is basically the same as enable batch processing. So it provides the same infrastructure beans, the same configuration parameters, and so on. You can use it, you can extend it in your class, and you will have those beans in the application context that you can, of course, auto-wire and use to build jobs and steps and so on. And now, since we are in a programmatic approach, if I want to override something, let's say the data source, I can override the method and write the code I want here to customize the configuration of my data source. So this is the programmatic counterpart of enable batch processing. All right, I will just check if we have questions at this point, and I don't think so. Okay, so I will move to the next feature. I think this is the batch configuration updates. So the next feature is the is about job parameters handling. So this is another impacting change in Spring Batch 5. So this is actually the way we convert parameters from the command line and the way we serialize them in the database and so on. And I will see what we have changed in this release. So as we know, maybe as you know, when with Spring Batch 4, we have a specific notation to specify job parameters on the command line, which is defined like this. So we have plus minus for the identification flag. So this is to mention if a job parameter is identifying or not. And then we have the parameter name. And then between parentheses, we have its type equals the literal value of the string of the parameter. And here is an example like java-jar, my job.jar. And then I have dash schedule.date. So this is the parameter name. This dash here is to mention that the parameter is not identifying. Then I have the type between parentheses, date, equals the value of the parameter. So this is how we specify job parameters on the command line with Spring Batch 4. Now, this notation has a couple of issues. The first one is that this dash here preceding the parameter name does not play well with Spring Boot. So with Spring Boot, when we specify parameters, we specify them with dash dash and so on. So that's the way to do it in Spring Boot. But when we parse those parameters, we remove these dashes from the parameter. The problem is when we remove them, one of them is like has a meaning for Spring Batch, and we lose that meaning, and that's problematic. So this is the first issue with this notation, which is like the incompatibility with Spring Boot. The second issue is those parentheses here. Those are incompatible with environment variables. So there are some circumstances where we pass job parameters as environment variables, like in Spring Cloud Dataflow. So for example, when we run batch applications in containers, we pass those parameters as keys, as environment variables. And unfortunately, we can't use parentheses in the keys of environment variables. So it's just impossible to do it, and that's a big issue. So we need to find a way to pass the parameter type without using these parentheses. And the third issue is the type here is ambiguous. So when I type date, is it a Java util date? Is it a Java SQL date? Which date type it is. So it's ambiguous, and I can't really know which type of date I'm passing here. So yeah, those are the issues with this notation, and that's why we try to rework and redesign the way we will pass job parameters to Spring Batch 5 in Spring Batch 5. So we have a new notation, which is like a standard key value pair. So we have a key equal a value with a specific interpretation for the value. So we have the parameter name equals the value itself. So it's a string literal, comma, the parameter type, and another comma, the identification flag, true or false. And here's an example, java-jar, my job.jar. Now I have schedule date. This is the parameter name equals the value, comma, the fully qualified type name. And then I can add comma, true or false. And I have omitted it on purpose just to show you that we can have some defaults with this notation. So if I don't have the identification flag, I can by default say it's identifying and so on. I think the type also can be omitted. So by default it's string, but yeah, here we specify it and we know that it's a Java time local date. This is the fully qualified name of the type. So with this notation, all the issues that are present in Spring Batch 4 just disappear. We don't have the dash here. We don't use it anymore. The type is a not between parentheses. It's written here in a fully qualified format. Of course, it's not ambiguous since it's fully qualified. And yeah, so those are the three issues that just disappear here. The only issue we have, and that can happen here, is that if the value of the parameter contains a comma, that's a problem because we don't know which part is part of the value, and the other one maybe will be parsed as part of the parameter type and so on. And that's the only issue that can happen here. That's why we added a new notation, which is the extended notation. Again, it's a key value pair, standard key value pair, with a specific interpretation of the value. And here it's a JSON object instead of comma separated list. So we have the value, the type, and the identification flag. And here is the same example with this notation. So schedule date equals, I have a JSON object here. And now if there is a comma in the value here, we know how to parse this in JSON, and there is no issue if like the value contains the separator here, which is comma. And yeah, so we have these two notations. If the default one is easier to use, of course, than JSON, but if there is an issue with having the separator in the value, you can always use this one as well. And this is actually inspired by the Spring application JSON property for Spring Boot. So this is actually a JSON object that you pass to your application, and this is the same idea here. So yeah, if you are used to this notation in Spring Boot, you should feel at home when you use it with Spring Batch here. So it's the same idea. So that's the first part, which is the conversion of parameters from string literals to values, how we convert parameters. Now, the second improvement we added here is about the parameters themselves. So in Spring Batch 4, for example, we have 4 types of parameters that we can use: string, long, double, and date. So we can only use these 4 types. It's a restricted list. This is sometimes an issue, because if I have a Boolean parameter, for example, I should find a way to like convert it from string to Boolean and so on. So I need to find a way to convert my personal type to one of these, which is a very restrictive list. So in Spring Batch 5, we redesigned the parameter types, and now we can support any type. So there is no restricted list. You can use any type as long as you provide a converter from string to the custom type and vice versa. And I have an example to show you how to do that. So for example, if I have like a batch job that exports orders of a given customer, and I want to specify the customer by name, so suppose that the name is unique. So I will write something like java-jar export orders job.jar customer equal foo. This is the customer name, which is like, let's say it's unique, comma, and the fully qualified type of the name, which is my domain customer. Now the idea is, how can I tell Spring Batch to convert this string literal foo to an instance of my domain customer? So, and this is where we need to teach Spring Batch how to do that. So the most natural way of supporting this feature is by leveraging the conversion service from Spring Framework. So we didn't like introduce new APIs or new interfaces. The idea is to use the service from Spring Framework, since Spring Batch is based on Spring Framework, and augment it with any custom conversion if needed. So how to do that? I have an example here. So I have this regular Spring Batch application configuration class. And if I want to use a custom type for my job parameters, I can specify a custom conversion service. So here I have my custom conversion service, which is based on the default one from Spring Framework. I can add my converters from string to my domain customer and the other way around, and then tell Spring Batch to use this conversion service using this attribute of the annotation. And with that, Spring Batch now can detect that a job parameter is of this type. It will take the corresponding converter and use it to convert the type to and from strings. And that's all. With that, we have like support for any type as a job parameter, not only for, which is, I think, a very good improvement. And you don't need to convert these booleans and other types yourself. You just use the conversion service from Spring Framework and you are done. So that's the second improvement in this theme, which is job parameters handling. All right, so before moving to the next feature, I just check if there is a question here, and I don't think so. So let me move on. Okay. The next feature is about batch metadata. So this is the metadata of Spring Batch in the database. We have a lot of changes here as well related to the features I showed. But yeah, we have a new databases supported for the job repository, and the first one is SAP HANA. So now you can use SAP HANA as a backend for the job repository of Spring Batch. So yeah, this is another one. This is a new product supported, and the other one is MariaDB. So MariaDB is not really new here. We used to support MariaDB, but before Spring Batch 5, it was considered as MySQL. So as you might know, MariaDB is a fork of MySQL, and the DDL syntax and so on is very similar to MySQL. So for a long time, we supported MariaDB and we considered it as MySQL. But now the fork, so MariaDB and MySQL diverged, and there is like feature disparity there. So we thought that it's the right time to start considering MariaDB as a separate product. So it has its own DDL schema, its own ID incrementer, and so on. So it's considered as a separate product, and that's why it's in this list here. So starting from V5, MariaDB is considered as a separate database product. It's not emulated like MySQL as in V4. So that's the first addition. The second addition is in the execution context. So we, as you know, we serialize the execution context of jobs and steps to the database. And in this release, Spring Batch 5, we changed the default format of the serialization. So in Spring Batch 4, it was JSON based on the Jackson library. And in Spring Batch 5, we changed this to base64 instead of JSON. And there are a couple of reasons for this choice, for this decision. The first issue is that when in Spring Batch 4, Jackson was a compile time dependency to Spring Batch. So when you import Spring Batch, you have Jackson as well in the class path, and many people were complaining because they were using other JSON libraries. So we had to make Jackson an optional dependency, so it's opt-in instead of opt-out. So that's the first reason. And the second reason is while Jackson, of course, is one of the best JSON processors on the JVM, it doesn't rigorously follow the semantic versioning rules. And this was like a bit problematic for us. Like if they introduce breaking changes in patch releases, or for minor releases we can understand, but sometimes for patch releases, and this was a bit problematic for us. So we had to make Jackson optional, and now in Spring Batch 5 it is an optional dependency. So we had to find another format that we can use from the GDK without any dependency, and base64 was the most natural choice. We could have used binary as well, but yeah, there was another discussion about this, and we chose base64. That said, you can still use Jackson and the JSON format. We didn't change anything to the implementation. You just have to configure the serializer, and you can have exactly the same behavior as in Spring Batch 4. Another improvement is to the metadata we put inside the execution context. So we added a new attribute, which is the batch version. This is a runtime information we take from the jar, and we add it to the execution context. So as you know, we have other attributes, the step type, if it's a restart or not. And now you have another attribute, which is the current version of Spring Batch. This is very interesting. When you migrate from one version to another, you can see the difference in the execution context, and you can know you are coming from which version and see the difference and so on. It's also good for debugging, so you can, while debugging, know which version you are currently using when you debug the execution context and so on. So this is a nice improvement in the execution context metadata.
And I'm just going to jump in. There was a couple comment things. So one of them is, hello, I tried to work with repository item reader, but it skips pages.
Oh, yeah. So this is not really related to the presentation, but yeah, I think there is one case when the repository item reader can skip pages, is when we change the criteria of when we read items. So for example, if you, while processing, you change one of the fields of items that impacts the the query that grabs items. In that case, in that particular case, the repository item reader is lost actually. If you change the state of the object itself, the repository item reader cannot like read subsequent pages, and you can see pages skipped. And that's the reason, I think. I can help on Stack Overflow if the person asks the question on Stack Overflow. We have an example that shows this.
Okay,
Yeah.
cool. And then the next one is it possible to use Spring AWS 3.0 SQS FIFO instead of RabbitMQ with Spring Batch 5 with leader and multiple workers for remote partitioning and chunking? Also, is it possible to have multiple leaders?
Yeah, so this is actually possible even with Spring Batch 4. I don't think we have changed anything to this in Spring Batch 5. We have an IMQP item reader, which you can configure to read items from RabbitMQ, or maybe for Amazon SQS, you need a custom reader. But for RabbitMQ, I know that we have an IMQP item reader, which you can use, in a remote partitioning or chunking. We have a sample of that in our sample suite. Also possible to have multiple leaders. I don't think so. This is a good question. I think the idea is to have, so if the manager node fails, can we have another leader maybe? I don't think so. It is not designed to work that way. So there is no leader election or something when the leader, the main leader fails. If the leader fails, workers will like continue working, and then you have to the job will fail. Of course, you have just you need to restart the job, and another instance of the leader will reconcile the status of workers. So yeah, that's the idea.
And then the next one is, does Spring Batch 5 support GraalVM?
Yes, I have a slide on this, and I kept it for the end because it's it's one of the major features. And yeah, just keep tuned. In a few minutes, you will see how Spring Batch 5 supports GraalVM. Yeah.
And then the last one for now is there any brief analogy to understanding batch metadata annotation?
I don't understand what batch metadata annotation is. For me, batch metadata is the everything related to the execution that is required to restart a job in case of failure, basically. So it's a runtime information that Spring Batch keeps on the side to survive any failure of the JVM. So it is actually the state of the execution. So when there is a failure, we can reproduce the state and continue the job from where it left off before the failure. So now talking about analogy to understanding batch metadata, I think the analogy is like when you are working on something, you just take note on where you are. And if you sleep and you wake up tomorrow, you know where you were. It's like a bookmark in your book, and that's what batch metadata is actually. I hope I answered the question, but at least this is how I understand it.
Cool. I will kick it back off to you now for your presentation. Thanks.
Okay. So schema updates. Of course, we had to change a lot of things in the database tables that Spring Batch uses. All of these actually cannot be really done in minor versions. That's why we did them in this major release. The first one is the usage of sequences instead of tables for SQL Server. So this is actually not a big change, but this is something very important to know if you use Microsoft SQL Server as a backend for Spring Batch. So up until version 4, we use tables to emulate sequences for MySQL for SQL Server. So it's we emulate sequences with tables. So even though we have sequences in SQL Server, so it's not like it's not the same thing, and it doesn't perform the same at the same level of as sequences. So in this release, we changed that. So if you use SQL Server, you have to migrate your DDL script to use sequences instead of tables. So this is technical, but I had to mention it. We also added a bunch of columns related to other features, and yeah, in different tables. So the goal here is not to go and explain all of them, but just to make sure to say that if you are migrating to Spring Batch 5, you have to be aware that there are many changes in the DDL scripts. So for example, here we added 3 columns in the batch job execution parameters table. So this is related to the job parameters feature, parameter name, type, and value, and so on. And yeah, so there are a couple of other changes. I added a link here to the migration guide in the wiki, and in which we list all the changes and some hints. And of course, we provide migration scripts that you can run on your current schema so that you can upgrade to the next version. Okay, so those were the changes related to batch metadata. I talked about the schema changes, the execution context, new database support, SAP HANA and MariaDB, and so on. So that was the major changes for the batch metadata. Now the next feature is about observability. So this is one of the most exciting ones, and I really like what we have achieved here. So we have 2 themes here, metrics and tracing, and I will start with metrics. So metrics were introduced in Spring Batch 4.2, actually, not even 3. But since 4.3, we introduced a lot of improvements. We fixed a couple of bugs. We fixed the tag names, so now they are consistent between different projects of the portfolio. So we have a consistent naming across the entire portfolio, and we had to change a couple of things in Spring Batch. We also upgraded the usage of observability APIs to Micrometer 1.10. So this is a major release, as I said, despite the minor version update. Yeah, we had to, they changed a lot of things in Micrometer, and we had to change them in Spring Batch as well. And we introduced a couple of new metrics. The first one is the currently active step. So this is very nice when you have a job with a lot of steps, and at some point you want to know the currently active step. So you can, if you have a dashboard, you can drill down and see, okay, my job is currently running step number 10, for example. So this is nice if you have a lot of steps. And the second metric that we added in this release is the job launch count. So if you have a job launcher in your application context and you use it to launch jobs, this metrics allows you to know how many jobs were launched by that launcher. So if you have a dashboard, you can see, like, since 2 hours, we launched 1,000 instances, for example. So yeah, this is the second metric we added in this release. So how to enable batch metrics? Metrics are not enabled by default. We don't want to introduce any overhead without your agreement. So how to enable them? So this is the classical Spring Batch configuration class. All we have to do is to add a bean of type observation registry. So this is from Micrometer. So once I have this observation registry in my application context, Spring Batch will detect it and use it for metrics. Of course, this observation registry should be configured with a backend that is supported by Micrometer, and that's it. That's all I have to do. So that's for metrics. Now I will talk about tracing, which is a new thing in Spring Batch 5. Tracing wasn't present in Spring Batch 4, and we added it in this release. And the idea of tracing is a bit different than metrics. So for metrics, we have like aggregate numbers about the execution time, the number of item read, written, and so on. So all are numbers. For tracing, we have a more detailed profiling, if you will. So we can trace the execution step by step. And the idea is to have tracing data somewhere and visualize it on a dashboard, for example. And here I have a screenshot taken from Zipkin. So this is like a UI for tracing. And this is a real Spring Batch application that I traced. And I wanted to show you what we can have in this kind of dashboard. So here I have a batch application, and I have a trace for a job execution. So I have a job called my job, and I see that the job took like 56 milliseconds here. And then I can see down that I have step 1, step 2. So my job has 2 steps, and I can also see the duration of each step. So here 10 milliseconds, here it's 6 milliseconds. And I can see exactly the execution time and the duration of each step and so on. So I see like there is a difference here. There is a period between the step 1 and step 2, and probably here I think the job is interacting with the job repository to persist the state of step 1 before starting step 2 and so on. So I can trace the execution instruction by instruction, and this is very, very interesting. Of course, if I activate database tracing, I can see the interaction of my job with the database. If I activate web component tracing, I can see like the traces for all web requests if my job sends a REST request or something like that. And this is very interesting to troubleshoot any performance issue with the execution. So on the side here, I can see other tags like the execution ID, the status, and so on. And I'm very excited for this feature. It's really awesome. I use it all the time now for all my jobs with Spring Batch 5. So another nice feature, if you have parallel steps, you will see them in parallel here and so on. And all of this thanks to Micrometer. So this is a feature from Micrometer, which we integrated in Spring Batch. So how can I activate tracing? So it's similar to metrics. I have my observation registry here. All I need is to configure a tracer, as long as it is supported by Micrometer, like Brave or OpenTelemetry and so on. So here is my tracer. It can be configured manually or auto-configured by Spring Boot. But once I have my tracer, I can add this default tracing observation handler with that tracer, and that's it. So with literally one line of code, I can like activate tracing, which is very nice way and very easy way to have this feature. And kudos to the observability team for making this as easy as one line of code, and I have like such invaluable tracing data, I think, like this. So yeah, that's tracing, a new feature in Spring Batch 5, and yeah, it's not activated by default. You can activate it like this. Okay, so the last but not least, of course, a feature I kept it for the end. It's GraalVM native support. This is a huge change. I'm really amazed by this feature. So what we have here is, you must know that GraalVM support is not new in Spring Batch 5. It was introduced in beta in 4.3. And since then, we have done a lot of work, bug fixes, performance improvements, tooling improvements with like the boot team, framework team, and so on. But yeah, this is an effort across the portfolio. All projects were involved, and the Spring Batch is no different. So we added also the native hints for AOT processing by Spring. This is the kind of work that every project in the portfolio had to do. We add the reflection hints, resource hints, and so on. All of these hints are necessary to natively compile your application to a native executable. And Spring Batch 5 contains all of these. You don't have to add them yourself. Now, why is this important? So native compilation with GraalVM allows you to have a better startup time, a better memory management, and improve the overall performance of your application. And for batch applications, we have 2 or 3 key metrics that we want to measure. And for that, we did a lot of benchmarks, but I will share with you 2 of them. 2 applications, a Hello World application and a file to DB application. I will talk about this in a minute. But the idea here is to compare the natively compiled application with a regular JVM application and see the difference in behavior and performance. So a Hello World application in Spring Batch is like a single step job that prints Hello World to the standard output. This is the application I am going to benchmark. So the first metric is the startup time. So I will compare the JVM app and the native app. So the JVM app took 1 second and 200 milliseconds to start, and the native app took 44 milliseconds. So this is 30 times faster, which is amazing. So the application starts much faster, which is great in cloud environments, for example, to start very fast. However, for batch applications, usually the startup time is not the most important metric, because if the application runs for a few minutes or hours, it doesn't really matter if it starts in a second or half a second. So what we measure typically for batch applications is the total execution time, like the duration of my entire job. And this is what we measured as well. So here we have the total execution time of the application. The JVM took 26 milliseconds, and the native application took 1 millisecond. So this is amazing, actually. This is 26 times faster, or sometimes it's more. On Apple M1, it's even more. It's 35, 40 times faster. But yeah, this is amazing because I can if I run my batch applications on a cloud platform that is built by CPU time or usage or memory and so on, I can have 20 times cheaper cost on that cloud platform, and this is really amazing. So this is a Hello World application, probably not very representative, and that's why we benchmarked another app. So before moving to the other app, I share here a link to a repository where you can find the code of this benchmark and the instructions that you can use to see the results yourself. The second application is more realistic. It's file to DB. So this is like we read data from a file on disk and we ingest it in a database, in a relational database. And the input file contains 1 million items. So this is a more realistic one. We have disk I/O, we have CPU, we convert items from strings to object and so on. So there is disk, there is I/O, and so on. So there is disk, there is CPU, and so on. Same metric, startup time. The JVM took 900 milliseconds. The native one took 40 milliseconds. So another impressive improvement on the startup time. And for the total duration, 37 seconds for the JVM application versus 15 seconds for the native app. So this is 2 times faster. It's not like the other one where we had 25 or 26 times faster. Here, because we have a lot of I/O, and it was a kind of expected, because I/O, you are bound by the disk, by the hardware, so you can improve the software as much as you want, but you can't really improve the hardware. And yeah, but still, it's 2 times faster, which is already a great improvement in my opinion. Again, you have the link to the benchmark repository. You can try it yourself. But yeah, I think this is very, very interesting to have this kind of improvement Of course, even if you are not running your applications on a cloud platform, it's still like an improvement on the execution time. Okay, just check if I have a question here. No, okay. So how can I natively compile my application? The easiest way is to start on start.spring.io. So you include the native dependency. And then once you edit your application, you can use the Maven or Gradle Goal native compile with the native profile. And with that, you will have a natively compiled application that you can run. So it's one command away and you have a natively compiled app. So it will take some time to generate this executable, but in the end, you have a natively compiled app that can start 30 times faster and run 20 times faster. So it's amazing, and kudos to the Spring Framework team, the Spring Boot team for the tooling, for everyone who is working on GraalVM to have this kind of improvement. It's really impressive, and I'm very excited for this feature. Oh, okay. So we have the links on the comments there. Okay, thank you. So that's the GraalVM support improvement. As I said, it was the last major feature I wanted to present, but definitely not the least. We have a lot of other features, but I'm not going to talk about them today. Just a very quick overview. We added a Maven BOM, so you can import all Spring Batch modules in a consistent version. We use now UTF-8 by default in all areas of the framework. We added transaction support in the Job Explorer and Job Operator. We also added the registration of a job operator with enabled batch processing. We also improved the system command tasklet. So we introduced a new interface called Command Runner. So nowadays we tend to run batch applications in containers, and in many cases we want to invoke a system command on the shell, and so we shell out from the Java application to the Unix environment and come back. So this system command tasklet allows you to do that. We improved test utilities. We migrated to JUnit 5. Yeah, so there was a lot of effort here. And also we improved the documentation to be consistent with other projects in the portfolio. So yeah, we have a page on the wiki with all the new features, and I will share it with you in the last slide. So that's all what we have added in this release. Now I will talk about what we have removed in this release. So the first thing we removed is the support for SQL Fire. So SQL Fire was deprecated, I think, in 2014, almost 10 years ago. So yeah, we removed the support for SQL Fire in Spring Batch 5. We also removed Gemfire support. We had an item reader for Gemfire. The issue here is that the reader was based on Spring Data Gemfire, which is not supported anymore. So we had to remove it in Spring Batch 5. We also removed the implementation of GSR 352. So this is the batch spec. And this is due to a lack of adoption of the implementation. So we didn't have any work to do on this implementation, and due to this inactivity, we decided to remove the implementation in Spring Batch 5. We also removed all deprecated APIs. So this is like a typical task in every major release. So all the APIs that were deprecated in 4.1, 4.2, 4.3 were completely removed. And here we have two links to the wiki where you can find the entire list of all the removed APIs and features. So that's for pruning. Now we'll talk a little bit about the support policy for Spring Batch 5 and most importantly, Spring Batch 4.3. So the support policy is the same as all projects in the portfolio, which is the VMware Tanzu support policy. Basically, it's 3 years for major, 3 years of support for major releases, 1 year of support for minor releases, minor versions. And we typically have the same support period as Spring Boot. So for example, for Spring Batch 5, since it's brought by Spring Boot 3.0, it will have the same support period as Spring Boot 3. For Spring Batch 4.3, it's brought by Spring Boot 2.7, so it will have the same support period at 2.7. There is a particular case where we have like a difference in the release cadence between Spring Batch and Spring Boot. So in Spring Batch, we release once a year. However, Spring Boot releases 2 times a year. So the particular case is if Spring Boot releases a version that still brings Spring Batch 5.0, for example, here if 3.1 is released and it brings Spring Batch 5.0, Spring Batch 5.0 will have the same support period as Spring Boot 3.1. So as long as there is a Spring Boot version that brings Spring Batch version, that Spring Batch version will have the same support period as the Spring Boot version that brings it. But yeah, the support policy is detailed in the this page. We have a dedicated page for support. You can find all the dates, the initial release, the end of OSS support, the end of commercial support, and so on. So the end of support here should align with the version of Spring Boot that brings the Spring Batch version, as I explained here. And yeah, this is always up to date, and you can find all the details here. The important thing I wanted to share with you is for the 3 line, it will be supported until November this year. So as you see, it's like 1 year after we released 5.0. So we leave 1 year of 1 year period for people to migrate from 4.3 to 5. And of course, if you need help, please reach out and we can help you move or migrate from 4.3 to 5.0. So that's all about support. The last thing I wanted to talk about is what's coming next. So Spring Batch 5.0 was released last November. It's behind us. What's coming next? What are we working on now? We will support 5.0 and 4.3 for the time being until they are the end of OSS support and the commercial support, of course. The last version we released a month ago, 5.02 here. And we are working on Spring Batch 5.1, which will be released in November this year and will be based on Spring Framework 6.1. And here we are working on improving the getting started experience. This was like the most asked feature in the Spring survey last year. So we heard we will improve the getting started experience. We are also working on supporting virtual threads from Project Loom. And we will make sure that Spring Batch 5.1 works correctly with virtual threads and as with platform threads. So correctness is the main focus here. And we also we are going to try to revisit the implementation of the chunk-oriented processing model. So concurrency, throughput, and so on. Probably we will leverage virtual threads. So we have a lot of ideas here. We will be sharing them on GitHub. So if you want to contribute, you are welcome. Those are goals, not commitments. We are doing our best, but if we don't ship those in November, please don't be surprised. But yeah, the roadmap and the progress is on GitHub, so you can follow the updates there. And with that, I think, yeah, that's all I have. So thank you for watching, and thank you for your time.
Thank you so much for doing this. This was really cool.
Thank you.
And yeah, thanks to everyone as well for asking questions and everything like that. And if you want to watch this again, it's going to be on whatever YouTube you're currently looking at, or Twitch, I guess, but Twitch eventually goes away. But if you're on YouTube right now, the same link will be the exact same link later. And if you just go again to tanzu.tv for the Golden Path Spring 1, you'll be able to just go on there and find the videos for this after it as well. So yeah, hopefully everyone has a good like rest of your day, morning, evening, whatever time zone it is. Like for you, I guess it's like 9-10 p.m. for you over there.
Yeah, exactly. It's fine.
And yeah, there's a thanks guys, keep it up.
Thank you.
So good job.
Yeah, thank you.
So yeah, all right. So thanks everyone. And I have a few little things to just go over. So let's see. All right, so first off, if you haven't heard of Spring Academy, you should go to spring.academy, and there's courses there that basically you can go and learn more about Spring, and therefore also Java. It's basic. There's a bunch of like hands-on things, and basically it's not just the kind like where you only listen to someone talk. You actually get to work on things too, which is super cool. Also, there, as I mentioned at the beginning of the talk, if you were here at that point, we have a Spring 1, which is happening in person August 21st through 24th, co-located with VMware Explore in Las Vegas. So you should go and get your tickets for that. So yeah, thanks again, everyone, and have a good rest of whatever you have left of your day.